Today we're going to talk about section 3.3. We've talked a lot about functions so far this semester and in this chapter, and today we're going to talk not only about our different types of functions but how we can represent them graphically. Before we do that, there's just some kind of keywords and some vocabulary that we want to go through and talk about. Right, so we're going to start with our definition of our rectangular coordinate system. Right, our rectangular coordinate system is what we usually think of as our XY axis. So our rectangular coordinate system contains the following parts: our x-axis, our y-axis, our origin, and 4 quadrants. Within these 4 quadrants, points are labeled by ordered pairs. Our ordered pairs are always alphabetical, x, comma, y. Right. So looking at this example of a rectangular coordinate system that we have here, I'm going to start by labeling some of these different parts. So our x-axis is our horizontal line. As we're looking at this is just like a normal number line. As we're going to the right, we're positive. As we're going to the left, we are negative. Our vertical axis is our y-axis. As we go up, we are positive. As we go down, we are negative. The point in the middle, right, is our origin. And our origin is the ordered pair represented by 0, 0. Right, we don't move to the left or right at all. We don't move up or down at all. So our origin is right there in the middle. Our graph kind of naturally separates itself into 4 different pieces. These 4 different pieces are what we call our quadrants. Right? The prefix quad meaning 4. So in our upper right hand corner we have quadrant 1. We generally use Roman numerals to label these. And in this quadrant we have moved to the right and we have moved up, so both x and y are positive. Right? To label the rest of the quadrants, we're going to go counterclockwise. So quadrant 2 is going to be our other quadrant that's up in the top area. Here we go to the left first, so our x is negative, but then we go up, so our y is positive. Right, then we continue moving. Now we're in quadrant 3. Here we have moved to the left, so our x is negative, and then we move down, so our y is also negative. So quadrants 1 and 3 have x and y's that have the same sign, both positive in that top corner, both negative down in this bottom corner. Right, then if we complete this, right, quadrant 4, again represented in Roman numerals, we move to the right, so x is positive. We move down, so our y is negative. So our even numbered quadrants 2 and 4 have 1 positive coordinate and 1 negative coordinate. Down at the bottom of this page we have a list of some different ordered pairs that we want to plot. So we're going to plot these, and as we're plotting these, refer to them and label them in our rectangular coordinate system that we have up here. So our first point is 6, 2. Right, so to plot this point, we always start at our origin. We're going to move to the right 6, 1, 2, 3, 4, 5, 6, and then move up 2. So that's point A that's represented by the ordered pair 6, 2. Again, we always move to the left or right first for x, and then we move up or down for y. Our next point listed, point B, is -1, -3. So we're going to move to the left 1, and then we are going to move down 3. So looking at these first 2 points, our first point was both positive x and y. We landed in quadrant 1. For point B, we were both negative. We landed in quadrant 3. Right, our next 2 points that are listed below are 4, -2 for C. So we're going to move to the right 4, 1, 2, 3, 4, and then we're going to go down 2 to get to this point. So this particular point we land in quadrant 4. Right. For point D, we have -5, 1. We're going to start by going to the left 5, 1, 2, 3, 4, 5, and up 1, and we land in quadrant 2. Right. So again, as we look at these, if we have one positive sign and one negative sign, that's how we land in either quadrant 2 or 4, depending on which one's positive and which one's negative. Our last 2 points listed down here at the bottom, they both have a 0, so they're going to land on our axes. So our first one is 0, 3. So that means we are not going to move left or right at all. We are simply going to move up 3 and put our point there. So E lands on our y-axis. Eventually we will call this point a y-intercept, but for right now we just want to pay attention to the fact that since it has a 0 in it, it lands on one of our axes. Right, our other point is -3, 0. We're going to move to the left 3. We're not going to move up or down at all. So this point lands on our x-axis. Again, eventually we will call this an x-intercept as well. For right now, we just want to pay attention to the fact that there is a 0 in there. Anytime we have a 0 in there, it's going to be landing on either our x-axis or y-axis, depending on which value is 0. In the last couple of sections, we've talked a lot about our different types of functions. Right? So we're going to look at these different types of functions, kind of talk a little bit about their shape, and go through, find some range values, and kind of make some generalizations about what these graphs of our functions look like. As we're going through these problems, notice that the instructions at the beginning of example 3 says that we're going to find our range values, plot the ordered pairs. We're going to lightly sketch the curve passing through the points. Right? So as we're thinking about these, again, we're still restricted to our integer domain. So the only points that are really going on our graph are going to be the ordered pairs that are integers. And then we're going to kind of sketch the graph to get an idea of what our shape is going to look like. We're going to see more of this, more of these types of graphing problems in chapter 5 later on down the road, but for right now we're going to focus on these 5 different types of functions. All right, so our types of functions that we've talked about, our first type is going to be a linear function. A linear function is that of a straight line. Our second type is a quadratic function. A quadratic function is that of a parabola. We briefly mentioned the other day that those are going to be U-shaped functions. Absolute value, those are going to be V-shaped functions. Square roots are going to be a curve. And then our rational functions are going to be a little bit more complicated, a little bit more involved, but we will work through and talk about sketching one of those as well. All right, so for this first one, for example 3a, we are going to graph a linear equation, f of x equals x. So this is an example of a linear function. Linear functions in general, we mentioned the other day, look like f of x equals mx plus b. So they're going to have a variable but no exponents or other symbols. They could have a coefficient associated with that variable x, and they may or may not have another number that's added or subtracted. In this first case, we're just going to keep it nice and simple, and we're going to make our x and our y values, or our f of x values, be equal. So if our x is 2, our equation says that our f of x is also going to be -2. If it is -1, again, we're not doing anything, we're just simply copying down our different values. Okay. So looking at our ordered pairs, again, oftentimes we think about ordered pairs as x comma y, but remember that our second variable, in this case, is our f of x, it's our range value. So as we're graphing them, we kind of use the idea of y and f of x interchangeably. All right, so our first ordered pair is -2, -2. So we're going to move to the left 2 and then down 2. Our next ordered pair is -1, -1. So we're going to move to the left 1 and down 1. Then we go through our origin 0, 0, right 1 and up 1, right 2 and up 2, right 3 and up 3. Okay. So these actual points themselves are the function that we are looking at. If we want to just make a nice little sketch of our function, I'm just going to kind of connect this, right? So that way we can see that this is called a linear function because our graph looks like a straight line. Right, our next type of function that we're going to look at. Right, here we have something that has a squared. Anytime we have something that's a squared, we say it is a quadratic function. We've talked a lot about factoring and solving quadratic functions in the previous chapter. Here we're going to look at graphing these. All right, so for our first one, our x is -2. Notice our function, our f of x equals x squared. So we're going to square -2. Remember, when we square negatives, negative times negative is going to turn positive. So our first value here is going to be 4. Right? -1 squared is going to be -1 times -1. Negative times negative gives us positive. 0 squared, well, 0 times 0 is still 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. Right, so we're going to start plotting these points. So our first point is -2, 4. We're going to move to the left 2 on our x-axis and then go up 4 spaces for f of x. We're going to move to the left 1 and then up 1 for our next point. Our third point is going to be at our origin. Our next point is 1, 1, so we move to the right 1 and up 1, and then we have the point 2, 4. Notice that we have kind of a mirror image if we were to fold our paper at our y-axis right now. If we sketch this in, it's not a perfect U-shape, but it is kind of close to a U-shape that we see for this. This shape, right, so our actual function is a quadratic function, and the shape that we're looking at here, this is what we refer to as a parabola. Thinking about our domain restrictions and our possible range values that we talked about before. When we're dealing with straight lines, we can plug pretty much any number we want in, and then as long as we get an integer out that's in our domain, we can use those. Looking at our parabola, we can plug anything in that we want to as far as integers goes. In this case, we just did a basic simple quadratic equation, and we got all positive range values. So one of the things that we talked about the other day were possible range values, and this kind of falls in line with that. Our curve that we see only exists up in the top portion of our graph. All right, our next function that we're going to look at is we're going to look at an absolute value function. Okay. Absolute value, remember, turns anything positive. We never have negative numbers that come out of absolute values. So if we take the absolute value of -2, it turns out to be +2. If we take the absolute value of -1, it turns out to be +1. If we take the absolute value of 0, it's 0. Absolute value of 1 is 1. Absolute value of 2 is 2. And absolute value of 3 is 3. Right, if we plot these, -2, +2, we go to the left 2 and up 2. Then we go to the left 1 and up 1. We put a point at our origin, which is 0, 0. We put a point at 1, 1, right, to the right 1 and up 1. Right 2, up 2 gives us 2, 2. Right 3, up 3 gives us 3, 3. If we were to sketch this one in, instead of getting a U shape like we did in the previous example, we get something that is more of a V shape, right, than a U shape. So our first graph was a linear, that gave us the shape of a straight line. Our second graph was a quadratic function, that gave us a U shape, and then our absolute value gives us something more of a V shape. Also worth mentioning for our absolute value, just like with our parabola from our quadratic function in the previous example, right? We only get positive numbers out, so that's one of the reasons that our curve is only living in the upper portion of our rectangular coordinate system. It's only in quadrants 1 and 2. Right, our next type of function that we're going to look at a square root function. Square root functions are also sometimes referred to as radical functions, but radical also encompasses other roots as well. We're going to, for our class, just focus on square roots. We talked a lot about square roots and their domains the other day. When we're dealing with square roots, remember that we cannot take the square root of a negative number. So that means as far as plugging -2 in, well, we're not going to be able to plug -2 in here. Right? As far as plugging -1 in, we're not going to be able to plug -1 in here. We can, however, plug in 0. The square root of 0 is still 0. Right? So we are able to take our square root of 0. Right? Our square root of 0 is 0. Our square root of 1 is just 1. Our square root of 2 does not work out evenly. Remember that these guys are irrational numbers. So our square root of 2, we can put a little squiggly equal sign. We can round it off to 1.4. Right? Our square root of 3, we can round off to 1.7 if we use a calculator. Our square root of 4 is 2, because 2 times 2 gives us 4. Right? So I'm not necessarily going to include these two guys in our table, right? Because as we are thinking about this chapter, right, these two guys right here, right, they are not integers. So we're going to try to do our graph without using those 2 points. All right, so our first point that we can use is 0, 0, so that's at our origin. Our next point that we can use is 1, 1. Right, I'm going to skip those guys in the middle, and then our last point is going to be 4, 2. When we draw this shape in, notice that unlike the absolute value graph that we see above where I put arrows going in both directions, because our graph continued going upwards in both directions, we do not want to put arrows in both directions for this square root. Right? Because we cannot keep going to the left. We cannot take square roots of negative numbers. So when we draw this sketch in, we're just going to sketch this going to the right. Tying in some other things that we have talked about in this chapter, when we were dealing with square roots, we said that we had to think about their domains, right? And whatever we have inside, in this case is an x, has to be greater than or equal to 0. So if we look at the values that we got, if we look at where our graph is on the side where x is greater than or equal to 0. All right, last but not least, we have a rational function here. Kind of like with the square root, we are definitely going to get some values that don't work out quite as nicely. And kind of like where we just ended with our square root, I want to think about our rational domain for just a minute. Okay? So if we're thinking about rational functions, remember that our denominator cannot be equal to 0. So that means that x minus 1 cannot be equal to 0. If we add 1 to both sides, that means that x cannot be equal to 1. So what that means is, looking at our table, right, we're not going to be able to use our value of x equals 1, just like when we were dealing with our square roots, how we were not able to use our negative numbers. We only got values for some of the things in our table. What's going to happen with our rational function is this value that we have here actually gives us something that we call an asymptote. Right? And our asymptote is a dotted line that we are not allowed to cross. So in my graph, before I do anything, through the value x equals 1, I'm going to draw a dotted line, and then when we sketch our curve, we cannot cross our asymptote. Right? So our asymptote is going through x equals 1, and our asymptote is a dotted line that we cannot cross. Right? Because we cannot have any values at x equals 1. All right, so let's focus on finding our function values then. Right? So we're going to plug each of these values into our fraction, into a rational function. We are going to get some fractional values as we're working through these. Right, so first I'm going to plug in -1. So f of -1 is going to be 1 over -1 minus 1, which gives us 1 over -2. Right? So we're going to think about that as a fraction of -1/2. We plug in 0. 1 over 0 minus 1 is 1 over -1, which simplifies to -1. And then we're going to do 1 over 1/2 minus 1, which gives us 1 over -1/2. 1 over -1/2 is the same as finding our reciprocal of -1/2. And if we flip our function 1/2 into a reciprocal, we're going to get a -2. If you're not comfortable dealing with reciprocals, if you type it in your calculator, you'll get the same thing. All right, down here we're going to continue plugging numbers in. 1 over 1/2 minus 1. That's going to give us a 1 over +1/2, which is 2. 1 over 2 minus 1 is 1 over 1, which is just 1. And 1 over 3 minus 1 is going to give us 1/2. So notice that as we're working through these, again, we have a couple of values that are not integers. So technically we should not be graphing these. However, in this case, I am going to include those values because they're going to give us an idea of kind of the shape of our graph. All right, so on the left side, again, even though it's not an integer, I'm going to plot the point -1, -1/2. Right? And I'm going to use the green here to emphasize that it's not an integer. So I'm going to move to the left 1, and then I'm going to move down exactly 1/2. So unlike the rest of the points that we've seen, right, this one doesn't land exactly on perfect integer pairs. Then we have the point 0, -1. So we don't move left or right at all, we move down 1. It lands on our y-axis. And then we have the point over 1/2 down -2. Again, not integers, so I'm not going to put it here in purple. I'm going to use the green instead. But we need that to kind of give us an idea of our shape. Okay. On the other side of our asymptote, we have 1/2, so we're going to go over 1/2 and up 2. Again, not integers. We go over 2 up 1. That one I'm going to do in purple because that is a function value that works because they are integers. And then we have 3, 1/2 for our last order pair, again, not integers. The reason I included these non-integer pairs is that gives us an idea of the shape of our graph. Right? So we were told that we can't cross the asymptote, and in this case we're not going to cross our axes either. And our rational function ends up kind of as these two curves on opposite sides of our asymptote, going in opposite directions that are kind of getting as close as they can, but not crossing both our asymptote and our x-axis.